And the y component is going to be 29.4 sine of 60. Looks like my x is in the negative direction. My y is also in the negative direction. Everybody still with it? So far, so good. So what's the normal force going to be equal to that? See, this column, the y column, should add up to 0. Yeah, whatever 29.4 sine 60 is, right? And doesn't it make sense that the frictional force is going to be equal to 29.4 cosine of 60? So to answer our questions, part A asks, what is the normal force? Normal force has an x component of 0 and a y component of 29.4 sine 60. So it's simply going to be that 29.4 times sine 60. We can use calculators for. We need to make sure you're in degree mode. So for part A, we've got 25.5 maybe. For part B, 29.4 times cosine. Questions on what we did there? Yeah, we did it. I think it's always going to work best to stay organized on sort of a chart. Like last year, you guys said you did like an X, Y chart, that's fine if you want to do it that way. Use X hat, Y hat, use J hat, K hat. Any of those is fine, but make sure you're staying organized. These are all my X components, these are all my Y. I think there was one thing we didn't get to that. We didn't talk about that. Why do we use a left-hand ratio sometimes? What's the static frictional force less than or might be equal to U times normal force? Well, kinetic friction is equal. Good. So if I push this way with 1 Newton and it's not moving, the static frictional force is going to be pushing 1 Newton back, right? It's not going to be greater than what I'm pushing. If it's pushing back at 2 Newtons, then it's going to be moving you back. The friction's never going to do that until we reach that maximum value of static friction. That doesn't keep it good. Example 11. Another one I want to do together here. Says we have a 2.5 kilogram box sliding down a 30-degree incline. This one has an acceleration. Part A asks us to find the net force of the box slides down the incline. How do we do that? This one actually doesn't require a lot of work. Are you doing that? Yeah. Force equals mass times acceleration. This is the net acceleration, is 4.3 meters per second squared. You get the net force and multiply that times mass. 2.5 times 4.3 is all we need. 10.75, 2 6 up there, 2 3, 10.8 meters right there. Easy enough. Part B asks us to find mu sub k. The only formula that we have that deals with mu would be frictional force equals what? Mu sub k times normal force, right? Frictional force equals mu times normal force. Mu, remember, is the coefficient of friction. No units on mu. So it looks like we need, in order to find mu, we need the frictional force and the normal force, which is pretty similar to the one we just did, right? Might want to sketch in a quick three-body diagram. 30 degrees. Force is acting on the box. Gravity. Normal force. We said there's a net force this time, right? I actually already found it, 10.8 newtons. Where'd that go? How are we going to do that? Obviously, the zeros are going to be the same as the last one, right? Normal force has an X of 0. Frictional force has a Y of 0. It's going to be going down the incline, good, which is in which direction? Negative X direction, right? And it's all in the negative X direction. So the net force of this is going to be sliding down the incline as an X component of negative 10.8. Let's actually use the non-rounded answer. Negative 10.75. And the Y component is 0. Most of the time, the Y component will be 0 because it's not going to be moving up off the incline, nor is it going to move down into the incline. Right? The Y component of that force, if it's moving up or down the incline, is going to be 0. We can split up gravity in the same way we did last time. This time our mass is 2.5, so the force due to gravity is going to be 2.5 times 9.8. Just like the last one, you could go in and draw this. Okay, this is going to be a 60-degree angle. So the X component is going to be 24.5 cosine of 60. And then negative X and 24.5 sine of 60. In the Y. Normal force, the Y component should be easy enough to fill in. Should just be positive 24.5 times 60. How are we going to get the X component of friction? Good. We are going to subtract it. If you're not sure, and sometimes it can be a little bit confusing, set up an equation. We're looking for this. So we would say negative 24.5 cosine 60 plus X should add up to negative 10.75, right? and then you would add that to both sides, add it over here, and we should be able to solve for x from there. We've got 24.5 cosine 60 minus 10.75. Looks like the x component of friction is 1.5. That was this side here, force due to gravity. We did 2.5 times 9.8. So far, so good? Yes. Yep. You should get exactly the same answer. The problem with that would be friction would have x and y components, normal force would have x and y components, and since it's sliding in that direction, now if you didn't rotate your axis, the net force would also have x and y components. But then it would be way more messy. Frictional force is 1.5. We can fill that in. I'm running out of room here. Normal force, as long as you rotate your axis, will always be in the y direction. So 1.5 for friction equals mu is what we're looking for. 24.5 sine 60. My normal force. Calculator should give it to us. Divide there. We're solving for mu. So if I have 1.5 equals mu times that, you get mu by itself divided by. That's the normal force. This is the frictional force. This is 1.5 normal force. So mu is 0.071. Always want units on our answer. Units from mu. Yeah, no units on mu. Anything else? But most other things should have units on there. Is that a big mu or a small mu? Yeah, it's pretty small. This object was sliding, which is why we found kinetic friction here. That was mu sub k. Could I do something similar here to get mu sub s? Could I use the frictional force right here and the normal force right here and say mu sub s equals whatever the force is? No, why not? It's a less than, yeah. You could say f sub s or f sub s is less than or equal to. So you could get the maximum value. We would say mu sub s is greater than or equal to this number. But you wouldn't be able to state explicitly what mu sub s is. That makes sense. Right. This one is holding it in place, so it's a less than or equal to. This one is moving, so you can find mu sub k. Any questions on example 10 or 11? I got what did you use 9.81 for? Yeah. Oh, I used 9.8. Notice on your grade sheet, it's 9.8. Yeah. So we